I'm Kurt Steger, and I teach natural sciences here at Paul Smith College. I've been here since 1987 and enjoyed every minute of it. And I've seen the transition from the college being a pure teaching institution to one that also involves research with the students. So I've been lucky to sort of be in the early days of that and help shepherd that process along. And what I'd like to do is explain a few things. One is how important having research at the college is, how it involves students and how it benefits the college. And also a little bit of what goes into this and what's required to make this happen. Our motto here at the college is it's about the experience. And our selling point, you could say, is not just the beautiful location, but it's the hands-on approach to education, that we really do it. We really walk the walk and talk the talk more than I think a lot of other colleges do. And as a science instructor, I like to get across to the students that science is more than just a collection of facts. It's also a process. It's a way of finding out information as well. A lot of us faculty do research, and it actually supports our teaching effort by modeling to the students how science is done. And it also generates activities and interest among the students as well. My research in graduate school at Duke University involved going to lakes in Africa, taking core samples down through the sediments in the bottoms of the lake, and then reconstructing environmental change over thousands of years. So the comings and goings of ice ages and evolution of species and things. So when I came here to Paul Smith's, my students and I built our own equipment to sort of do a smaller version of what I was doing on a larger scale at Duke. Based on those research opportunities with the students and myself, we've gradually have built up a full-fledged international scale research program to this. One of the most exciting things is to watch the students light up when you tell them you're going to find out something that no one has ever known in the history of the world before by studying these lakes. So the basic technique is we have different ways of collecting the sediment. One of them is this. We can go to a bog or a lake and walk out there, shove this down in vertically like this, and then with these rods up here, either up from a boat or through the ice, we'll rotate this and it'll close and we'll pull it up. And when we do, we've caught a section of mud here with all the layers in it, going back through time, technically as far back as the Ice Age. It was in 1999. I was just finishing a lecture about evolution of fish and the research I used to do in Africa on the lakes. And I mentioned this lake that's famous among biologists where these fish have evolved in place over thousands of years. But the question was, how old was the lake itself? How many thousands of years old? So how long did it take those fish to evolve? And I mentioned it as a mystery that could be solved by coring. After the class, 4 students cornered me right in that hallway right there and said, why don't you write a grant proposal and take us to Africa and we'll find out how old the lake was? So I said, okay. And it worked. We actually got the grant. I took 4 students as a team to Lake Victoria in East Africa with the National Science Foundation and some other groups as well. And we cored down through the lake, found out it was 5,000 years old, a little older than scientists had thought, one of the most famous evolution sites in the world. And we ended up publishing a peer-reviewed paper with students on the paper. And people refer to this now. Since then, I've taken, I think, a dozen students to different parts of Africa to do this kind of research. When you do get published in the literature, you get press coverage. So the National Science Foundation, who funded this, also helped promote this information, and we got international coverage. You can search it out on the web. So we've got student co-authors on papers. That helps their career. It's great free press for the college. And of course, this all feeds back and helps you get the grant cycle going as well. It's always interesting to look in the distant past and find out when the Ice Age ended and how fish evolved in Africa and things like that. But this kind of research now has a special relevance in the Adirondacks, in the region where we are right now. Now that climate change is on everybody's minds, especially in the last year or so, when we've had these wild floods and droughts and fires and things like that too. So coincidentally, I was realizing with the students that we actually know less about the history of the Adirondacks in terms of climate history and environmental history than we do of Africa, where we were working. And this turns out to be really important because in addition to having a very good chance that we're going to live in a warmer world that these students are, there's also going to be change in precipitation, either getting wetter or drier. And here's where our kind of work becomes really important, because the models that people are using to look into the future conflict as to whether this region is going to get wetter or drier in the future. And if you can imagine how important that is, that'll have to do with frequency of forest fires, floods coming and going, lake levels of Lake Champlain going up and down, and those kinds of things. Well, it turns out our technique of sediment coring can answer a lot of those questions by looking at the past as a model for what the future holds. And it also feeds back into the teaching as well. For example, in the introductory biology course, which I help to teach, we do a lot of hands-on activities where we go to the lake and sample the lake, look at the plankton. We're saving those data that the students take, and we're building up a long-term monitoring program of what climate change is doing to the lake here. And we've already got, it goes back to 1990 actually. So it's a very valuable scientific tool to look to the past for clues to the future. Once you have your really good research, then you have to publish it, and that takes peer review, and it needs to be in a reputable journal. For example, the biggest journal in the country is called Science. It comes out every week. And I've had 2 papers show up in Science, and when that happens, based on the research of this sort, or for example, the South Africa study that was just recently published with students got a lot of press as well. That's where it comes from. People come to you if you have something interesting to say that no one else knows. You get that from your research. So there was years of work leading up to this that was done behind the scenes before you get this big media push. I recently published a book called Deep Future about the long-term future of climate change from a historical perspective, and that's been sold around the world. Here's a Spanish translation just came out. It just came out in paperback, and they're selling it in Taiwan, and went on a book tour in Australia. So whenever I go, I mean, I'm presenting myself as the professor from Paul Smith's from the college, and I talk about the experiences with the students as well. It's a finely tuned, closely interacting system that requires a lot of time and energy to do it, a lot of background work that's invisible unless you know how this kind of a system works.